So, the question requires us to find three factors that determine the width of confidence interval for the mean. Firstly would be confidence level. The confidence level shows how sure we are that the true population mean is inside the interval. For example, if we choose a higher confidence like 99%, we want to be more certain that the mean is within the range, so the interval will become wider. However, if we choose a lower confidence level like 90%, we are less certain and the interval becomes narrower. Second would be the size of margin of error. The margin of error is the amount added to and subtracted from the sample mean to make the confidence interval. If the margin of error is large, the interval will be wide, meaning less precision. If the margin of error is small, the interval is narrow and more precise. The margin of error depends on the confidence level, the sample size, and also standard deviation. Third is standard deviation. This tells us how much the data varies. If the standard deviation is large, the data is more spread out and the confidence interval will be wider. That means we are less precise about where the true mean is. But if the standard deviation is small, the data is more consistent and the confidence interval is narrower, giving us a more precise estimate. So the next question. A grocery store wants to know the average number of gallons of milk it sells daily. It is known that the sales follow a normal distribution and the population standard deviation is 5.10 gallons. A sample of 60 days shows the average daily sale is 10 gallons. The store wants to calculate a 99% confidence interval for the true mean. Hence, we will use the confidence interval formula for a known standard deviation, which is sample mean plus or minus z value times population mean over square root of the sample size n. Firstly, we will substitute the values into the formula. We will get 10 plus or minus 2.576 times value in a bracket, which is 5.10 divided with a square root of 60. Second, we will calculate the standard of error in the bracket. Hence, we will get 0.658. Now, we will multiply it with the z value. Hence, we will get 1.696. Lastly, 10 plus or minus 1.696. This gives lower limit 10 minus 1.696, we will get 8.3. Upper limit 10 plus 1.696 equals to 11.7. So the answer of this question is the 99% confidence interval is 8.3 and 11.7. This means the store can be 99% confident that the true average number of gallons of milk sold per day is between 8.3 and 11.7 gallons.
Hello everyone, so now let's take a look at the question C, which is we are told that a sales screen printing company purchases t-shirts and selects a sample of 300 t-shirts at random. Out of the sample, 15 are found to be defective. The question asks us to construct a 95% confidence interval for the proportion of defective t-shirts in the shipment. Let's go step by step. Step 1 is identify the sample proportions, which is to find the sample proportion of defective t-shirts. We use the formula P equal to X over N, so where X is the number of defective t-shirts, which is 15, N is the sample size, which is 300. So P equal to 15 over 300, so we will get the answer is 0.05. This means that 5% of the sample t-shirts are defective. Now we move to the step 2, which is step 2, use the confidence interval formula. We will use the confidence interval for the population proportions. P plus minus Z times square root of P, open brackets 1 minus P, close bracket over N. So for a 95% confidence level, the Z value is 1.96. Substituting the values into the formula, so we will get 0.05 plus minus 1.96 times square root of 0.05 times 0.95 over 300. First calculate the standard error, so square root 0.0475 over 300, so we will get the answer square root of 0.0001583, so we will get the answer 0.01258. Now we will multiply by the Z value, so 1.96 times 0.01258, so we get the answer 0.0247. So the confidence interval becomes 0.05 plus minus 0.0247, which is give us two answers, 0.0253 and 0.0747. So the conclusion for part C is we are 95% confident that the true proportion of defective t-shirts in the entire shipment lies between 2.5% and 7.5%. Now let's move to the question D, which is we need to determine required sample size. A local politician wants to estimate the proportion of people who support their fiscal policies. She wants the estimates to be within 0.06 of the true proportions. The advisor believe that the true proportion is around 0.60 or 60%. We are also told to assume 95% confidence level. The goal here is to find how large a sample is required. For step 1 is use the sample size formula for proportions. The formula to calculate the required sample size is n equal to open bracket z squares times p open brackets 1 minus p close bracket over e squared close brackets, where z is 1.96 for 95 confidence, p is equal to 0.60 and e is 0.06, which is the margin of error. Okay, now we will substitute all the information into the formula, and n equal to open bracket 1.96 close bracket square times 0.6 times 0.4 over 0.06 square, 4 power of 2. So we get the answer 3.8416 times 0.24 over 0.0036, 0.921984 over 0.0036. So the final answer is 256. Since sample size must be a whole number, we always roll out, and n equal to 256.
Assalamualaikum, my name is Muhammad Amirul Mukmin, metric number 304551. Today I will answer from past year questions. Question 3A, and I will explaining how to tackle the answer for the question. First, let's start with leave the 5 stages procedure for hypothesis testing 5 marks. We have to list down all the 5 stages. First stages, the hypothesis state the hypothesis null, or we call it hypothesis HO, that equal to mu, that is our statistic mean. And then we also state the alternative hypothesis, or we call it HA, that not equal to mu. That means is mu are changing. Secondly, we select the significant level. For example, we choose a 0.010 significant level, 0.1 significant level, 0.025 significant level based on our questions. Then we select the test statistic. Neither we use z-test or t-test. It depends on are we known or unknown the standard deviation. Then we use the test formula. For example, t-test, we put in all the information needed to the formula, and we make decision based on what we have calculated, z-value for example, and what z-value from the table that we have got that being provided. And then we decide either to reject or to accept the null hypothesis, or we choose the alternative hypothesis. Okay, we will continue to the next question, is 3B. Our first question are related to this. We have to use the step where we have learned from the first questions, and we will apply it in this question to answer all the given questions. A manufacturer want to increase a shelf life of a cake mix. Past record indicate that the average shelf life of mix is 216 days. After a revised mix has been developed, a sample of 9 boxes of cakes mix had a mean of 217.2222 and a standard deviation of 1.2019 at the significant level 0.025. Decide if the sample data support the claim that shelf life has increased, and state your deviation in terms of null hypothesis. Okay, first what we have provide is 216 days is our mu, our average shelf life, highlighted that. After that, we use a sample size of 9, highlighted that, that is our sample size, 9 boxes, and our mean is 217.222 and standard deviation of 1.0249. And also highlighted our significant level is 0.025. Okay, but we have learned and we collect from this question. First, we use the first step is state our hypothesis. Our null hypothesis, or HO, mu is equal to 216. That means our shelf life has not increased. Next is HA, or alternative hypothesis. Our mu are bigger than 216. Our shelf life has increased. And next step, we take our significant level, alpha equal to 0.025, and we decide. The third step, we decide what is formula that we will using, our z-test or t-test. From the information given, we see that we don't have any standard deviation of a population. We just have a standard deviation of a mean of sample, that is S 1.029, and we have to use t-test for these questions. First, list down all the information given, that is mu equal to 216, our S bar is 217.222, our standard deviation of a sample S equal to 1.2019 and our N or sample size is 9. Okay, we will continue to using the t-test formula. This is a t-test formula. S bar minus mu divided by S divided by square root of N. We plug in all the numbers that we have given from the question. Is 217.22 minus 216 divided by 1.2019 divided by square root of N, and we got 305. After we calculate, and we have to look at our t-table to confirm our value are the same or not the same. Before we continue to the table, we have to find degree of freedom, that is n minus 1. Our n is 9, minus 1 is 8. At the significant n, also we have to know our significant level, that is 0.025. And we got our t value is 2.3006. How we know that our t value from the t table are 2.306? We can look at the table provided here. At the significant level of 0.025 and degree of freedom of 8, we can see that from the table we got 2.3006. This means that our null hypothesis should be rejected because our value, t value that we have calculated from the question are not the same as the t value from the table. That is, we reject the null hypothesis and using the alternative hypothesis, that is our mu are more than 216. And we can see that our shelf life having increased, and that is what the answer is. Yes, the life of the chef cake mixes are increased.
Assalamualaikum Doctor, my name is Muhammad Sabri, metric number 30443X, and I will continue explaining about past year exam, which is from the same paper, which is question 4B. The question is to compare the effect of weather on sales of soft drink. A distributor surveyed people in 2 regions of the country and asked if they purchased soft drinks in the last month. The following are the results. The distributor would like to know if there is a difference in sales between the 2 regions. So what we can see, there is region X and there is region Y. And it says test the hypothesis with a 0.01 significance level and tell what is our decision. So what we get from the data is we get sample size from region X, which is 1000, number who purchased from region X, which is 400, and sample size from region Y, which is 1500, and number who purchased from region Y, which is 500. So what we can do first is we take sample proportion from both regions. The formula would be number who purchased divided by sample size. So for X, we will get 400 divided by 1000. So the sample proportion would be 0.4. And from the region Y, we will get 500 divided by 1500. And our sample proportion for region Y is 0.333. The first step that we can do is we need to state the hypothesis, which is the null hypothesis, which is P1 equals to P2. That means no difference in proportion between region X and region Y. And second hypothesis is alternative hypothesis, HA, which is P1 does not equal to P2. That is a two-tailed test for a difference. And the significance levels is alpha equals 0.01 like stated earlier. Step 2, we find the pool proportion, which is PC equals X1 plus X2 divided by N1 plus N2. And we will get 400 plus 500 divided by 1000 plus 1500. And we will get 900 divided by 2.5K. So our pool proportion is 0.36. We will get the same answer using the same proportion earlier, which is 0.4 plus 0.33 divided by 2. It's also the same answer. For step 3, using two sample test of proportion, we are going to find the Z value. The formula is P1 minus P2 divided by square root PC multiplied by 1 minus PC divided by N1 plus PC multiplied by 1 minus PC divided by N2. So we will get 0.4 minus 0.33 divided by square root 0.36 multiplied by 1 minus 0.36 divided by 1000 plus 0.36 divided by 1 minus 0.36 divided by 1500, and we will get 0.067 divided by 0.0196, which is 3.42. So our critical value of Z is 3.42. So the last step, which is step 4, we need to find the Z value for significant level alpha 0.01. since our degree of freedom is bigger than 200, so we will use infinity. If we look at the table, we will get our Z value, which is 2.576. So since our calculate Z value earlier is 3.42, which is bigger than 2.576, we will reject null hypothesis. So in conclusion, our decision is there is sufficient evidence at the 1% significance level to conclude that there is a difference in soft drink sales between region X and region Y.